Is Earth the only celestial body harboring life, or do we have company in the vast universe? This is the fundamental question that has driven humans to gaze at the stars for centuries. Welcome to the captivating world of astrobiology, a field that combines elements of astronomy, biology, and geology to unravel the mysteries of life beyond our home planet. Astrobiology is not just about finding little green men on Mars. It's about understanding the principles of life, its origins, and its evolution. It's about peering into the distant reaches of the cosmos and asking, could life, as we know it or as we might not know it, exist there? From the icy moons of Jupiter to the potentially habitable exoplanets orbiting distant stars, astrobiology seeks to answer the age-old question, are we alone in the universe? Let's delve into the breakthroughs that have propelled this exciting field forward. Life is resilient, and sometimes it thrives where we least expect it. Picture a world of boiling hot springs, freezing glaciers, or acidic bogs. Sounds inhospitable, doesn't it? Yet in these extreme environments on our very own planet, we've discovered organisms that not only survive, but thrive. We call these remarkable life forms extremophiles. The discovery of extremophiles has turned our understanding of life upside down. They've shown us that life is hardier than we ever imagined, capable of enduring conditions that would quickly kill most other organisms. From the scorching heat of hydrothermal vents to the icy depths of Antarctic lakes, these extremophiles have made a home. The implications of these discoveries are far-reaching. If life can flourish in Earth's most hostile environments, might it also exist in the harsh terrains of other planets or moons? Imagine a microbe, similar to those we've found in our deepest oceans or driest deserts, eking out an existence on the frozen surface of Europa or in the stormy skies of Venus. This is the promise of extremophiles. They provide a tantalizing glimpse of the potential for life beyond Earth. They challenge us to broaden our search, to look in places we might previously have dismissed as too extreme. Because, as we've learned, life is not only resilient, it's full of surprises. If life can adapt to Earth's harshest environments, where else might it be hiding? In 1996, a rock from Mars sparked a heated debate. This was no ordinary rock. Named ALH 84001, this meteorite was found in Antarctica in 1984 and later identified as a Martian meteorite. The excitement around ALH 84001 was not just about its origins, but what scientists found inside. Structures that resembled fossilized bacteria. Could this be evidence of past life on Mars? The microscopic structures were certainly striking, resembling what we know as nanobacteria. But could these really be Martian fossils? Critics pointed out that similar structures could be formed in non-biological processes. The debate raged on, with no conclusive evidence to prove either side. The Mars meteorite ALH 84001, despite the controversy, served a significant purpose. It forced us to think outside our Earth-centric view of life. It challenged us to consider that life could exist in places we never imagined, in forms we never considered. Although the debate remains unsettled, ALH 84001 challenged our ideas about where life might exist. The universe is teeming with planets outside our solar system. This statement is no longer a mere speculation. Thanks to the advances in technology and relentless pursuit of astronomers, we are now certain that there are countless worlds beyond our own. One of the most significant breakthroughs in the study of astrobiology is the detection of exoplanets. These are planets that orbit stars outside our solar system. The discovery of these cosmic bodies has dramatically broadened the scope of our search for extraterrestrial life. The first exoplanet was discovered in 1992 around a pulsar, a rapidly rotating neutron star. That was a surprise, but the real game-changer came in 1995 when astronomers discovered an exoplanet orbiting a sun-like star. This discovery sparked a new era in the search for life beyond Earth. Since then, we've detected over 4,000 exoplanets using various methods. The most common method is the transit method, which involves observing the dimming of a star's light as a planet passes in front of it. Another technique is the radial velocity method, where scientists look for slight wobbles in a star's movement, caused by the gravitational pull of an orbiting planet. These discoveries have not only given us insights into the variety and complexity of planetary systems, but also fueled our hopes of finding life elsewhere in the cosmos. After all, if there are so many planets out there, surely there must be life somewhere, right? With billions of exoplanets in our galaxy alone, the odds for life seem more promising. In the search for life, we've started looking for signs in the skies of distant planets. These signs, called biosignatures, are substances in an exoplanet's atmosphere that may indicate the presence of life. They can be anything from oxygen to methane, but it's not as simple as finding these gases and proclaiming Eureka. We have to consider geological processes that could also produce these gases. Recent years, however, have seen some intriguing potential biosignatures. One of the most notable instances is the potential detection of phosphine in the atmosphere of Venus. Phosphine is a gas that on Earth is only associated with life, either as a byproduct of biological processes or human activity. The detection of this gas on Venus, a planet with a harsh environment that we once thought was incompatible with life, has sparked intense scientific interest and debate. But it's not just our neighbour that's getting all the attention. Scientists are using sophisticated telescopes to analyse the atmospheres of exoplanets light years away, looking for those precious biosignatures. The hope is that one day we might detect a biosignature that can only be explained by the presence of life. Detecting biosignatures on distant planets brings us one step closer to finding extraterrestrial life. And who knows, maybe in the not-too-distant future, we'll be able to confirm that we're not alone in the universe. Curiosity may have killed the cat, but it's bringing Mars to life. Let's talk about the Curiosity rover, an intrepid explorer that has been roaming the red planet since 2012. This car-sized robot is on a mission to find out if Mars ever had the conditions necessary to support life. One of the most significant discoveries made by Curiosity is the evidence of past water on Mars. Imagine a Martian landscape not too dissimilar from our own, with rivers, lakes, and perhaps even an ocean. Curiosity's findings suggest that such a scenario isn't pure science fiction. Ancient streambeds and mineral-rich clay deposits provide compelling evidence that Mars once had liquid water, an essential ingredient for life as we know it. But that's not all. Curiosity didn't stop at water. It found something even more tantalizing: organic molecules. Now don't get too excited. These aren't little Martian microbes. Organic molecules are simply compounds made of carbon and hydrogen, and sometimes include oxygen, nitrogen, and other elements. They're the building blocks of life, but not life itself. However, their presence on Mars raises the intriguing possibility that life could have existed or might still exist in some form. Curiosity continues its journey across the Martian surface, each discovery adding a new piece to the puzzle. This rover's ceaseless exploration and the information it provides have transformed our understanding of Mars. Curiosity's discoveries have made Mars a prime target in the search for extraterrestrial life. The icy moons of Jupiter and Saturn may be more alive than we previously thought. Europa, one of Jupiter's largest moons, and Enceladus, a smaller moon of Saturn, are both enveloped in thick layers of ice. Beneath these frosty exteriors, however, evidence suggests the existence of vast subsurface oceans. These are not small ponds we're talking about, but bodies of water larger than all of Earth's oceans combined. These subsurface oceans exist because of the gravitational pull of their respective planets. This gravitational dance generates tidal heating, keeping the water from freezing solid and creating a potentially habitable environment beneath the ice. And that's not all. Recent missions have detected plumes of water vapour bursting from the surfaces of both Europa and Enceladus. These plumes are believed to be connected to the subsurface oceans, providing tantalizing hints about their composition. In the case of Enceladus, these plumes have been found to contain organic molecules, the building blocks of life as we know it. The potential for life on these icy moons is not as far-fetched as it may seem. On Earth, we've found life in some of the most extreme environments, from the crushing depths of the Mariana Trench to the icy wastes of Antarctica. If life can thrive in these conditions, why not in the subsurface oceans of Europa and Enceladus? These icy moons, once thought barren, could be promising locations for life. Are we alone in the universe? The answer may lie in our ability to detect signs of technology. Imagine a civilization, light years away, going about their day, using technology much like or perhaps vastly different from our own. Can we pick up the signs of their existence? This is where the search for technosignatures comes into play. Technosignatures are signs of technologically advanced civilizations like us, who are capable of altering their environment in ways that could be detectable from interstellar distances. One of the most well-known examples of this search is the hunt for extraterrestrial radio signals. Radio waves travel at the speed of light, and they can carry information across the vastness of space. For over 60 years, scientists have been scanning the skies, listening for any sign of these artificial signals. This is the basis of SETI, the search for extraterrestrial intelligence. But technosignatures aren't limited to radio waves. They could be anything from laser emissions to patterns of light caused by artificial structures, to signs of large-scale engineering projects like Dyson spheres. The possibilities are as limitless as the universe itself. The search for technosignatures is a long and arduous journey, and we may not find anything for a long time, if ever. But it's a search worth undertaking, because if we do find something, it would not only redefine our understanding of life, but also our place in the universe. The search for technosignatures aims to answer the age-old question, are we alone? The much-anticipated launch of the James Webb Space Telescope will revolutionize our search for life. Imagine a telescope so powerful that it can peer into the farthest reaches of the universe, glimpse at the earliest galaxies being formed, and observe the atmospheres of distant exoplanets. That's the James Webb Space Telescope for you. This colossal piece of machinery, the size of a tennis court, is no ordinary telescope. It's the largest and most advanced space telescope ever built. Named after James E. Webb, the second administrator of NASA, this telescope is equipped with a primary mirror 7 times larger than that of the Hubble Space Telescope. This allows it to collect more light and observe the universe in unprecedented detail. But what makes it so crucial in our search for life? Well, the James Webb Space Telescope is designed to observe the universe primarily in the infrared spectrum. This ability is key to detecting biosignatures, or signs of life, in the atmospheres of exoplanets. By analysing the light that filters through an exoplanet's atmosphere, the telescope can identify the chemical makeup of that atmosphere. This opens up a world of possibilities. It means we could potentially detect signs of life on planets light years away from us. The James Webb Space Telescope is not just a tool for observing the universe, it's a tool for answering one of humanity's oldest questions. Are we alone in the universe? The James Webb Space Telescope is set to usher in a new era in our search for life beyond Earth. As we stand on the brink of new discoveries, the future of astrobiology is more exciting than ever. As we cast our gaze outwards into the cosmos, we're not just looking for new stars and galaxies, we're searching for signs of life, indicators of existence beyond our blue planet. The next big leaps in astrobiology are poised to come from upcoming missions and technologies. We're not just talking about telescopes peering into the depths of space. We're talking about advancements in robotics, AI, and even biotechnology that could drastically change how we search for extraterrestrial life. One such mission is the planned exploration of Europa and Enceladus, 2 of Jupiter's and Saturn's moons respectively. These celestial bodies have been the subject of much speculation because of their subsurface oceans. Scientists believe these oceans could harbour life, and upcoming missions aim to explore these icy moons in greater detail than ever before. Then there's the development of new technologies to detect biosignatures on distant exoplanets. Imagine being able to detect the faintest signs of life from light years away. These technologies are currently in their infancy, but the potential they hold is astounding. Furthermore, the integration of AI and machine learning in the field of astrobiology is opening up new avenues of exploration. These technologies can process vast amounts of data far quicker than any human could, potentially speeding up the search for extraterrestrial life. Finally, let's not forget about the role of biotechnology. Scientists are studying extremophiles, organisms that survive in extreme conditions on Earth, to understand how life might exist in harsh environments elsewhere in the universe. This research could provide insight into where we should look and what we should look for. As we continue to explore the cosmos, who knows what we will uncover next? The universe is full of possibilities. The stars above us are not just twinkling lights, they are invitations to explore, to question, to dream. The future of astrobiology is as boundless as the cosmos itself, and we are just getting started. Thank you for joining us on this cosmic journey through the fascinating world of astrobiology. We've explored the possibilities of life beyond Earth, the potential of new technologies, and the exciting future of astrobiology. As we continue to gaze into the cosmos, we invite you to join us. If you've enjoyed this journey and want to be part of the next big discovery, remember to hit the like button and share your thoughts and theories in the comments below. Are you excited about the exploration of Europa and Enceladus? Do you believe in the potential of AI and biotechnology in the search for extraterrestrial life? We'd love to hear your thoughts. Don't forget to subscribe and hit the bell icon so you won't miss any of our future adventures into the cosmos. And if you know someone who shares our curiosity about the universe, feel free to share this video with them. Together, we can explore the universe and its endless possibilities, because the universe is not just above us, it's within us, waiting to be discovered. So let's keep exploring, questioning and dreaming. After all, we are all stardust, and our journey is just beginning.